So how was the keynote sessions? Were you there?
Mm. That's a little bias. No. Okay.
So welcome to DevOps. My name is Hanneli, and this is Breandan. And we are going to be talking a little bit about types in Kotlin, Java, and Scala. So quick disclaimers before we actually get into the presentation. We will select a single example, and we are going to be working on the same example over and over again. So sorry about that, it's going to be repetitive, but we are going to implement the same idea following different strategies. This is not a language war. We are going to try to select cool features from Java, Kotlin, and Scala, and we are going to be talking about them and comparing them. So the goal here is discussing some architectural examples and not really getting into a real project.
That being said, there might be a little bias. I think I'm a little partial to one of these languages, but we'll leave it up to you. You'll get the full scope of all of what we're looking at. So a few days ago, or a few weeks ago, we started exploring this idea of different languages that we're interested in, and I've recently been using Kotlin a lot. And we were thinking about how we could apply these ideas to different domains. And just as an example, one example might be Android on mobile. So you have UI frameworks in lots of different languages. For example, if you have a vertical and a horizontal layout, these are very common things to have inside of a framework that you're using. So we're just using this as a toy example. And we're thinking about, well, how might you be able to do this in different languages to make it as fluent, as kind of natural as possible. So sort of a very classic example in Java is to use inheritance, where you have a concrete superclass, a layout class, and you're extending that with two different subclasses, vertical and horizontal layout. And the superclass might be an abstract class. You might not be able to instantiate that. But you have this idea that whatever's in the superclass, you're inheriting these concrete methods, and you're able to access them from these subclasses. This is sort of very classic OOP inheritance. There are some benefits and disadvantages to this. Very often, when we do this, we're introducing a very tight coupling between this superclass that we have this idea that it's a super type of these other things we're implementing. So there's this coupling problem that if we change something in the superclass, we're going to have to change a lot of things maybe in the subclasses. And this is not always very desirable. Another issue is that very often people will extend the superclass to just gain access to those convenience methods. So if you have something that's not exactly related, but you want to be able to perform certain methods and have access to certain properties inside that superclass, then you might just extend it without thinking about the consequences later on. So this is one way to solve it. So what's another way that you could model this domain?
So what would you do? There is a hint on the screen. We know that inheritance could work, but how can we make this design better? Hi, good morning. Please talk to me. I know it's basic stuff, but you can make an interface. Thank you. We had coffee earlier today. So we could come up with an interface and actually create concrete classes, vertical and horizontal, that actually implement this interface. And we could get some benefits by adopting this design. We can lose the couple between the classes because the main idea of an interface is actually asking the object if it has or if it doesn't have a certain skill set. In other words, the idea of an interface is about asking the object if it understands a certain protocol, a certain contract, right? Does it make sense? So we could come up with a naming refactor because keeping the idea of layout is not really a skill set. We are really talking about the orientation protocol. So just a quick refactor here. We are switching from interface layout to actually interface orientation. And then we keep the two concrete classes implementing orientation. All right? All happy? It's time to add some methods to our demo classes. So let's think about rotate. You probably have a mobile device, and sometimes you're trying to play a game, and then you switch to a different layout, right, to do a certain set of activities. So what happens when you rotate? Well, if you rotate a horizontal layout, you are expected to get a vertical layout, right? And vice versa. If you rotate a vertical layout, you're expected to have a horizontal layout. How can we implement these methods, and where should we implement them based on the set of classes that we have? So we have this. Where would you implement that? Sometimes when you don't know what to do, you just get the classes that are actually going to be affected by the method and just implement the method on them. Something like that, right? So you have horizontal, and then if you rotate, you end up with a vertical, and you have a vertical, and then if you rotate them, you end up with a horizontal. What else could you do? It looks a little bit repetitive here. What else could you do? Please. Put on the interface. Yes, great. So that could enforce that those classes, vertical and horizontal, need to satisfy a contract, right? You're forcing people to actually implement rotate. But the main question for you, does rotate actually is meant to be a thing of orientation, or if it's a matter of layout being rotated? What do you actually rotate? What do you actually change? It's the layout. So if you think in terms of...
You might be able to rotate like other things other than orientations, right? You might...
Yeah, so if you think in terms of layout, we could come up with a better solution to actually rotate a layout. So we talked about inheritance, we talked about interfaces. What else do you have in mind for approaching the same problem? Composition. That's good, we didn't cover that. Thank you. We could also think about something like that. A layout that has a generic parameter t, right? Does it make sense? A layout vertical and a layout horizontal. And that's a very different approach. So what could we have here? We could come up with a class of a layout t and come up with two concrete classes, vertical and horizontal, and then they would be combined together. There is no hierarchy involved here. They are like communicating to each other. What's wrong or what's missing here? It's also missing that, but why? Because you need to restrict the domain of layout. Having a layout of string wouldn't make much sense, right? Maybe, I don't know, we never know. But in terms of mobile development, you want to restrict the domain to vertical or horizontal. So how do you do that in Java?
Like you said, you can add a parent of these two types, right? So for example, if you had these two and you want to parameterize this as part of a type of layout, then what we could do is say that these both, like we did before, they extend this interface, and we're going to use this as a type parameter. And so we're saying here in Java, very simply, that it has to be either a vertical or a horizontal or an orientation. It has to be of type orientation. So this is setting up a bound on our type. We give it the type. We could just give it the type, but then we could pass anything to that. We could say this is a type of string, and it might make sense. So we want to bound this by orientation. It has this is an upper bound of this type. But the question is, how do we implement this this generic layout? If we define this in our superclass inside of this orientation, then we're going to have to say, well, we'll return an orientation. There's no way to say either we return a horizontal or we return a vertical, depending on which one we are right now. So there's this idea of state. And typically, this is maybe done inside of a runtime method. So you might be able to do like some if, else, then check sort of thing. But what we also want to do is we want to say, well, can we restrict this something like this? We want to have a layout horizontal, and then pass it this. And then when we rotate this, we want to get a vertical layout.
Yeah, so to kind of address one of the inconveniences that Breandan was talking about is that imagine that we instantiate a layout horizontal, passing horizontal as a parameter t, and then we call the method rotate, right? The type that's going to be returned is orientation. Do we really want that? Not really. We want a layout vertical. That's much more meaningful for us. So what's going to happen when we call rotate? We need to cast, right? We need this explicit casting. So is there any way to avoid that? Turns out, yes.
So we would like to bake this kind of safety into our type system. And in Java, this is a little bit difficult to do. But I was exploring a way to do this in Kotlin. And in the same way that we have an orientation and some things that implement that interface, these are going to be types in Kotlin. And it looks very similar to Java. Just go back one sec. So it looks very similar to Java. You have these functions, and you're overriding this rotate. And inside of our layout class, we're going to have a type. And don't worry about what out means right now. We'll explain that later. We'll gloss over that right now. But this is going to be of type orientation, again, supertype. This is basically the same thing as t extends orientation. And this is going to accept a t as part of the constructor. Right, so if we have this, then we also have this nice feature called extensions in Kotlin. And extensions allow us to add members to a class or an object or some type outside of the definition of that class. So for example, let's say this is in a library somewhere. You could define this extension in your code. The scope would be inside of a package or wherever you define the scope to be. Here we're saying the scope is inside this package by default. And then now what we're able to do when we call this layout, what we can say is, so just notice two things here. I want to point out that they're the same name, and they accept no parameters, right? And they're defined on layout. So in Java, the signature would be the same. We would not be able to put this inside the class. But in Kotlin, what we can do is define this on a generic class of type, of a concrete type. So this rotate that returns vertical will only be available on a layout of type horizontal. And likewise, this other rotate that returns horizontal will only be available on types of layout verticals. So when we rotate them, it will return the opposite thing. And when we compile this, or when we need to use this annotation called JVM name, when we compile this to make this interop with Java, because we need to give it a special name. But if we're just using Kotlin, we're safe. So this is how we use it. We can say, we can create a horizontal layout, and we can omit the type parameters here because Kotlin does inference for us. So we'll just say this is a horizontal and a vertical. And then once we rotate that, we'll add the type parameters below just to make this very explicit, but you don't need those. That v is a layout vertical, and we're assigning horizontal.rotate, and this will compile. The same thing with horizontal. If you rotate a vertical, you'll get a layout of type horizontal. And so this allows us to really to bake this into our type system, which is a nice thing to have. So if you accidentally rotate a horizontal and assign it to horizontal, you won't be able to do that. It'll fail with a compiler error. If you can rotate it twice, it's the identity, right? But if you do the identity and assign it to a different type, then it does not compile. So the things on the bottom do not compile.
So I am a big Scala fan, I've been learning Scala for a while. And the way I would implement such thing in Scala would probably be something like that. I would come up with a trait called orientation. And then again, keeping the same design of having vertical and horizontal as concrete classes that actually implement this trait. And then come up with an abstract class that receives a parameter t. And the t needs to be any child of orientation or orientation itself, which means we are going to have vertical, horizontal, or orientation. And then one thing that I probably would think about doing is creating a concrete vertical layout class that extends layout vertical. Unboxing this idea of vertical layout. And I would do the same thing for horizontal layout, but of course extending layout horizontal. Unfortunately, the GIF didn't work, but it was a funny one. You might be wondering, why do you have so many classes? That's so annoying. Well, it turns out that it's not too many classes. I'm just trying to express a different idea. So when you have orientation, either for inheritance or interfaces, you have vertical and horizontal actually in a creating some sort of hierarchy. When you come up with the layout, you box this hierarchy into something else. And by creating layout vertical and layout horizontal, we are actually extending this idea of a box, but with different responsibilities. So that's why I would go into such approach. However, if we get tied to this previous code here, where we have this layout receiving a type t, something interesting is going to happen. It probably makes sense in terms of domain, assigning the type of layout orientation and actually instantiating a horizontal layout, correct? Because horizontal is a subtype of orientation, so it probably would make sense assigning layout of orientation would be totally valid if we wanted to instantiate a child of it. But it turns out that Scala is going to give you an error. So the compiler is going to be unhappy. Why does it happen? So turns out that telling the Scala compiler that T is going to be a subclass of orientation, or orientation itself, is not enough. We need to tell the compiler that layout horizontal is a subtype of layout orientation. We need to give this extra information to the compiler. Otherwise, the compiler will not know what to do, because we're not telling this. So we need to add the plus sign here. And that's what we call covariance. It's a beautiful name. Lots of people like telling about covariance and things like that. But that's the idea of covariance.
So would you say that the outer, the container, sort of the type, it matches the hierarchy of the contained type?
Yeah.
It follows the same relationship.
The same way that horizontal is a child of orientation, layout horizontal is going to be a child of layout orientation. We are following the same idea for both the box and the inner elements. Another function that we could think about implementing would be a Rerender function. Sometimes lots of games need to re-render your screen or things like that. And you actually want to keep the same layout, but you just want to re-render parts of your screen. So if we try to implement this method called Rerender, passing a layout t, what's going to happen? We should be able to do that.
Any guesses?
Yeah, you got.
Someone's.
We got an interesting error here. Like covariant type occurs in contravariant position. It's interesting because look at the number of results, like 2,170 with like the same question. Like Stack Overflow has a bunch of like marked as duplicate. I don't think it's a very intuitive error when you're like trying to learn the language and you get this random error. And you think like, why contravariant? I don't get it. So imagine for a brief moment, I hope that Scala people don't want to throw rocks on me. But imagine that you could do such thing. Like, imagine that you could do something like that, which you can't, but imagine you could. The problem here is that you could easily come up with a layer orientation and instead say that with horizontal layout. We just saw that's possible because of covariance, right? So we are applying the behavior of the inner elements to the box elements. But for the same reason, due to polymorphism reasons, we could totally pass a new vertical in here. We would be allowed to do so. And that doesn't make any sense for Rerender. So that's why we need this inner parameters to be contravariant. So this thing would be totally wrong, and our code would be broken. So that's why you need the arguments to be contravariant. So one interesting thing that we noticed by writing code in Scala and Kotlin is that those languages kind of reinforce us to think about concepts that we usually didn't think in Java. Contravariance, covariance, and generics itself. So that was a very interesting approach.
Yeah, I think I'm a little partial to this language, but I think that if we can have this sort of baked into our language as well. So we want to have to be thinking about what variants our types are. Then what we'd like to do is have this explicit. In Java, you have to remember this mnemonic, PECS, producer, extends, consumer, something like that. I forget what it is, but it's not obvious to me, like why this is why we need to do this. So in Kotlin, we have these words in and out. So let's go back to our example. And it seems to me like this is a little bit more intuitive than this plus and minus in Scala, but it's the same thing basically, right? So we have our orientation, and this is the interface that we're implementing, just like before. And we have these two things that provide orientations, horizontal and vertical. And here, notice we're using this object instead of a class. So it turns out that if we're creating classes all over the place, this isn't very efficient. We'll just use object. Object is the Kotlin version of a singleton. So you can say object, and there's only one object. So you can just reference it without any...
it is the same, pretty much the same thing for Scala.
Yeah. Here, we'll go over out. So here we have an out parameter. And what this means is this will only occur in the out position. So we can only return t's. We can never accept t's as a parameter. So what does that look like when we go on and call it? Well, if we have a builder of out t, and this t is generic layouts. We have a builder of generic layouts. We can return t out. So this is only going to occur in the return position. So this function build will return the same type as whatever its parameter is. So this is fairly straightforward. Similarly, if we want to render this, we can only accept t's. And t's can be layouts. Here we don't mention that. But we're only going to allow this in the in position. So if we had a t in a return position in this function, then this would not compile. So let's see how this works semantically when we want to call this. So for the covariance example, we have a horizontal builder that is a builder of horizontal layouts. This is a particular type of the generic builder. And the second parameter here, we have a layout builder, which is a generic layout builder. It will know how to build all kinds of layouts, like vertical layouts and any other kinds of layouts. So here, this is a function, and it's not really important. But if you're trying to demonstrate something with types, it's useful to use this type of method because you don't have to instantiate a whole bunch of stuff. So you have it all in the parameter. You say, someone's passed me this. OK, I'll deal with it. So we have a builder here, and we can put a horizontal builder into a generic layout builder because Even though it's a horizontal builder, it's a specific type, it will conform to this contract. It will allow us to build layouts. Even though it's just a specific type of layout, it follows, it's a subtype of that. So layout horizontal is a subtype of layout orientation, and a builder of layout orientation is a supertype of horizontal builder. So they follow the same relationship. However, if we try to assign a generic layout builder to we try to assign it to this thing that's wrapping it inside of a horizontal layout builder, then this creates an error because we're returning T's, and this needs to return horizontal layouts, not generic layouts. It needs to be a specific thing, which generic layout builder doesn't know how to return horizontal layouts. So it follows the same relationship. Any questions about that? If we go to the contravariance example, the opposite is true. So this is some just you think about when we're accepting T's. So if we have a generic layout renderer, this will know how to deal with horizontal layouts. So we can box this inside of a horizontal layout builder. And if we receive horizontal layouts all the time, then we know how to deal with that since we're a generic layout builder. Likewise, if we try to do the opposite, if we have horizontal renderer boxed inside of a generic renderer, then we'll be able to handle generic layouts. We won't be able to handle generic layouts because we're a horizontal renderer, right? So this will not work. The second example will fail to compile.
So one thing that we had to deal with for all these examples we were building was type erasure. So the languages built on the top of JVM are going to lose the T parameter. So our interesting layout class receiving a generic parameter is going to become this creepy class layout. So that's one of the effects of type erasure. And sometimes it could be a little bit inconvenient depending on how you want to represent your classes. For example, imagine our layout classes. It could be really meaningful if we could keep vertical and horizontal. I was really surprised with Kotlin, actually, with the extension functions. Turns out they're pretty handy.
I don't. So it turns out that these are not actually defined inside of the class. They're just defined outside, and they'll remain outside, and they're statically resolved. So in the same way, anything that you can do with generics, you can do without generics. You just have to add a lot of casting and instance of checks. It just makes it a little simpler to deal with if you're able to use
syntax a little bit better.
Generic types.
But you still need to handle with the type erasure. So for Scala and Kotlin, we realized that there are some strategies to try to work around the type erasure itself. So for Scala, for example, we have two popular libraries called type tags and shapeless, which can be pretty handy by keeping the type fields for you. In Kotlin, we saw that extension functions can be helpful as well. I think you've mentioned that there are Reified Generics in Kotlin.
Right, and this will only work for inline methods. I don't know what the strategy is for type tags and shapeless. They may sort of memoize these and instantiate, hold instances of these types. So they might be able to add some overhead to your performance. So there might be a performance hit there. In Kotlin, for example, this is all sort of figured out by the compiler. So you don't have to worry whether this is going to have a performance impact. And it's a very limited form of generics, Reified Generics. That's one way to access the T, if you have Reified Generics, inside of the method. Usually, you lose the T. You can't access that as a concrete type. But with Reified Generics, you can use the T inside of your method.
Well, we've seen some other strategies that you can actually use reflection to get an information and instantiate the class again as a field. Or some people recommended us, why don't you manually store T in a field so you can see lots of code on GitHub that actually performs this strategy. But again, those are workarounds to handle with the type erasure and from the JVM. So why is this important? Well, besides thinking about the domain, how you are going to represent your problem with boxes and hierarchy and things like that, at least for me, I started focusing on problems or on concepts that I wasn't familiar with or I wasn't used to pay attention when I was writing code in Java. For example, when I was learning Scala, I was really surprised because for me, using the upper bounds and lower bounds from Scala or covariance and contravariance, the plus and the minus symbol, made like things easier for me to understand and handle with.
Yeah, I had the same experience. So coming from the Java background, you're constantly taught these OOP patterns. And in school, you read effective Java, and this idea that you have interfaces and the hierarchies for classes. And things have to fit into this sort of strict hierarchy. So you have this hammer, and everything starts to look like a nail, where everything has to fit into this supertype subtype relationship, superclass subclass relationship. And it doesn't always fit the domain model. So we started to see a lot of different frameworks start to use these ideas from DSLs, where you have some language that you're embedding inside of another language. And if you use types effectively, type systems like Scalas and Javas, you can build sort of IDE agnostic, generic frameworks that if your tools implement these type checking semantics, then you'll be able to encode a lot of the rules that you have in documentation about frameworks into your type system, so that when you press the period and you open the parenthesis, you'll get a type that exactly fits that shape that's supposed to go into this function. So that's something that I'm particularly interested in with DSLs and fluent interfaces. And maybe if I'm lucky, I'll get to show some cool examples in Kotlin, if she lets me.
I think we're going to have like 10 minutes, so.
If you have any questions,
Yeah. Another thing that we could handle better was understanding the good and the bad parts of these languages, because we can pretty much interchange Java with Scala and Java with Kotlin. So you can really get the downsides of each language and put them to work well together. So that's one of the benefits that we got from here. So here are some of the references for you. So here is the shapeless that I mentioned, one of the strategies to work around the type erasure in Java. We added a few interesting blog posts here. This is one of my favorites, generalized types without a PhD. I like the way the author exposes some of the concepts like covariance, contravariance, and so on. He actually has I think it's a series of posts without a PhD. So like lambda calculus without a PhD and things like that. So that's I totally recommend this blog post. This is the type tag library. Do you want to mention your examples in Kotlin?
So there's some great documentation in Kotlin that explains a lot of the covariance and contravariance stuff, specifically with respect to generics and wildcards. So Kotlin doesn't have these wildcard generics that you have in Java, and it uses a slightly different, more restricted form of generics, but it's still available. You can implement a lot of the same things. And we have all our examples in a GitHub repo, so those will be available to check out in this presentation afterwards. And I guess we'll open it up to questions and some examples if we have some time.
Any questions?
Mm-hmm. Let's get the mic.
I'm just wondering if you have looked at the Reified Generics coming in Project Valhalla for Java, and how that will benefit bytecode generation in those languages, Kotlin and Scala?
Yep. So I know a lot of people, the question was whether the Reified Generics in Java 10 or beyond, I don't know what it's targeted for, would maybe affect these other languages that are built on top of the JVM. As I understand it, you can implement Reified Generics on the JVM yourself if you want. Maybe they could leverage that from this added functionality. So maybe like in Java 8, they added like this invoked dynamic instruction in the JVM. So maybe there will be specific instructions that these other languages will be able to leverage. If that has to do with compiling the language, like the Java language, down to bytecode, then maybe that's all implemented in some compiler tricks to get that to work on the existing bytecode. I'm not sure.
It's actually planned to be new structure in the class files that will support it.
Okay, so then if that's true, then maybe these languages will be open to extending, implementing these new instructions. It's a question that I guess you'd have to ask the community. And I assume it would have enormous benefits for people who are writing libraries like collections. I know that there's a lot of sort of hacks that they do to get access to memoizing these types and things like that so that they have access to them later. If you talk to any of the people who've built a collections framework, there's some great sessions here about that. They'll tell you that Reified Generics would be great to have. So I certainly hope that maybe Scala
I've seen a little bit of the project itself. They didn't decide about the final syntax for it. We were at JFocus, I guess, and we saw an interesting presentation about that. So the syntax is not defined, but I really think it's going to help all the language on the top of JVM, because one of the major complaints of the people developing languages for the JVM, they say sometimes we feel limited about what we can do. And in Scala, for example, they fall back to a different compiler outside of JVM. So I guess it's going to bring more languages to the top of JVM, because the JVM has a wonderful architecture that could benefit a bunch of other languages that just don't jump into, because they're afraid to get tied to some of the limitations. So the more they expand the set of features, they can bring more languages to it. Any other questions? I'm blind.
Yeah, more of a thought than a question about Reified Generics. There is this prevalent idea that Erasure was a mistake, that Reified is better and all this, and I like to dispel that in the sense that Erasure is a very much superior approach to this than Reified Generics. Erasure is what allowed all these languages on top of the JVM that we're using today. The fact that, for example, .NET has Reified Generics was the main reason why Scala.NET was abandoned, because they couldn't port the type system of Scala to the Reified .NET types. So there are also a lot of other advantages to Erasure. One of them being that it keeps you honest, in the sense that once the compiler has validated your code and has been able to prove properties about your types, then all these types go away and you're not allowed to do reflection or things like that, which will actually second guess the compiler and will lead to more fragile code. So it's a very, very large discussion. I don't want to derail it too much, but Erasure is here for a reason, and it's actually a very, very good way. Reified is kind of planned. They're thinking about it, but it will always be on top of everything. It's never going to replace Erasure, and I hope it doesn't, because that's why we have such a beautiful ecosystem.
Yeah, I know a lot of our language architects it's kind of a holy war, but I know that the stewards of Java are very reluctant to add this feature for many years. Whether that's changed or not, I'm not sure. But no type system is perfect. Even Java right now has a type system that's, it's Turing complete. You can run arbitrary programs on the type system itself. And it's difficult to prove a lot of the semantics about it if it may or may not halt, or it may produce incorrect output. So that's kind of as an aside, but I think it would be interesting to explore how that would apply to Java, maybe in the future. And
like we said, we didn't criticize type erasure because accessing the project Valhalla page, it's written. It's not meant to, interfere in that. And we totally understand the point. But sometimes, depending on what you're doing, sometimes you wanted to get rid of that or just work around it for a reason. And the question is, can we come up with more efficient workarounds that we have to write less code for that particular case that we want to keep the type? That could be a question, and that's completely valid to ask. Not about removing the feature of the language, but can we make it better when you have a side case? I guess that's a better question to address.
Was there another question from that side, or did we? Yep.
I just had a question. Obviously, your experience with Kotlin, I was wondering if you had started in Java.
Mm-hmm. Yes.
And when did you move to using Kotlin?
Mm-hmm. So interestingly enough, I didn't use Kotlin for many years. I worked at two companies that both used Kotlin, and it wasn't until I left the JetBrains. I worked for JetBrains for 2 years, and after that, I started exploring this language, and it's pretty cool. So it's easy for a Java developer to kind of get into the syntax, and you don't have to migrate everything. So you can just migrate parts of your library, your code, and it'll work interop with Java very smoothly. So I find it sort of very natural extension to Java. You get a lot of benefits of more succinct functional programming. If you're writing libraries and DSLs like this, you can do fully type-safe DSLs. So you have a lot of these things that are in text files. But what if you were able to embed this in your language? It looks pretty much like another language. There's not a whole lot of braces in here. You don't have to, even with Java 8, you get a bunch of extra braces. So it's not, there's a little bit of extra ceremony if you're doing these sort of things. And it's really designed around Java developers. So whereas Scala might have a little steeper learning curve, I enjoy writing Scala. I've been doing it a little bit. And it does implement some pretty advanced concepts in type theory that are useful to have, but maybe not as practical or as easy to understand for someone who's reading it.
So when you made the move to Kotlin, what did you find as your biggest barrier coming from Java?
I'd say, so in Java,
Or was it just really easy to do?
yeah, it's a good question. So probably this idea that you have to kind of manage these nulls in Java when you're working with Java, and where to intercept or where to make sure this is not null. So in Kotlin we have this idea called null safety, where it can't be null unless there's a null question mark afterwards. So we have all these annotations. The question is, like, where do we enforce this if you're working with a Java library that produces nulls? That was a little bit tricky for me, but it's easy to get used to that, and it provides a lot of benefits as well. And I guess also this idea, I'm not really a functional programmer, so getting into the swing of things with streams and map, filter, reduce, as well as this DSL idea where you have these Lambda functions with implicit receivers, which is just kind of a little complex, but it's easy to get your head around once you've done it a few times.
Well, I guess our time is up. So we are going to be around. So thank you very much for coming to our session.
Thank you.